Hello. Today I'm going to describe Siemens NX CAM module. Let's get started. The details in this tutorial series. Actually, I'm going to start with the CAM module. Then maybe we can do it in later the CAD sections as well. And the first, if we're starting from the zero, you need to actually have a CAD model to be machine. So I have actually created a new model. So I simply start with the cylinder since we are actually doing a late turning operation. So I actually select the Z axis as the cylinder axis and a point which is 0, 0, 0, the center of the bottom circle. So the diameter is 50 by 250, the height. So I have created a cylinder. This is this will be our finished product. So we need to actually create a bonding body that actually resembles the blank geometry. There is a command under the base and more. There's a bonding body. Also, you can just search from here bonding body. Yeah, you can create a workpiece blank. The axis is auto detected, so it is Z axis and the point is 0, 0 again. And I added the 2 mm offset here, which is our blank geometry. So this is simply, there are some other ways in creating geometry in Siemens NX, but in this tutorial, I'm not going to actually describe the CAD section. Maybe we can do it in upcoming tutorials. Now we can switch to manufacturing. So under the application, there's a manufacturing here, or you can just in the shortcut Control Alt M is another way. So we need to set up the machining environment. So the first thing is CAM session configuration. This will be mostly counted as CAM general, but there is a Lathe here, CAM filter it out, and CAM setup to create is turning. So this is our operation navigator. So we are going to use the operation navigator to create the toolpath. And under the operation navigator, there's a program order view, machine tool view, geometry view, and machining method view. I'm not going to give all the details, so let's maybe delete them all. And let's start with the geometry. Since we are just making a simple turning, we don't need the counter spindle or sub spindle coordinate system and all making coordinate system. Also milling coordinate system. We will just create a pure turning operation. So there is a main spindle coordinate system here, and I'm going to actually move this coordinate system to here because this is the fixture side, so the machine side. So there will be a fixture here, so we may not reach by either cut tool or probe to make the adjustment of G54, which is the actual program 0. So it can be somewhere reachable, physically reachable. So I have actually aligned the part axis or the normal of the other end to Z axis, because in turning the convention is Z and X axis. So Z axis should be in the along the axis, the parallel or coincidence with the part axis, and D in the diameter direction, something like this. So this will be reachable. So I actually select the bonding body surface I didn't select the part surface because we cannot reach here. We can just, we need to touch here, and this will be 0 in the physical machine. And also the program coordinates should be according to this coordinate system. So we can actually create the workpiece main. The part is, yeah, inside. So this is the inner part is our sorry, this is the inner part is our, why it's coming like this. Yeah, inside cylinder is our finished product, and the blank is our Alps. We need to create a turning main. This will be actually created to the contours of the part from the 3D. So I need to select the boundaries of the part that's actually auto-created because this is actually what we the first we define the MCS. It will be according to MCS. We automatically created the part boundaries, but you need to be careful that the tool side. This is the small sphere that defines the tool side here near the arrow should be the outside of the contour because we will machine the outside. Plane can be automatic. It will be auto detected, or you can just specify it. It's very easy. So, well, here is the blank side. It will be again the outside. So, we don't need 3D geometries, so we can hide them by actually selecting those by Control B and again Control B. Now you have 2Ds. You can just, sorry, F8. You need to go to the closest orthogonal view. So you would see something like this. The avoidance is actually you need to define the movements of the machine tool from the machine home position until the part. There is a from point. From point is if you select the from point, the machine starts movement from the home position to from position. So you can actually adjust this as 2500. So there should be safe place because from the home position to front position, the machine actually moves in the rocket movement. So the motion start, we can actually axially and radially somewhere here. Let's say 0, 90, another 50. Approach is another point that we need to approach. 60 to 300. Motion start to engage. Can be axial radial. It's okay. Then departure point, same as approach. Motion to return point. It can be. It can be radial axial. Same as start. Go home. It's again radial axial. Yeah, there's a similar something like this. So let's create some cutting tool, sorry. Let's insert a cutting tool here by right click on the generic machine, insert tool. There's some tool types also. You can just select the tools from the library, but there's no library in me, so I need to create a cutting tool. Yeah, you can see it's something like rotated, but I can select work coordinate system under more. Then let's select the main spindle. Also, there is a tracking. Tracking is the point where the tool is tool center actually. This is tool center of the tool or tool pad. The tool actually run on the tool pad by following this point. So you can change it to the radius here. The tool pad will be actually calculated according to this position. So if you use some probe, tool measurement probe, you can actually you need, if you enter the radius of the tool, it will be actually accept this as a center point. If you touch manually, you will use this point, but it's up to you actually. It's according to your process. For this one, I don't want to use the turning adapter because I don't need it now. The tool holder, you can make the tool holder adjustment as the dimensions. You can enter dimensions. I'm using the left-sided tool because the position of the tool will be something like this. And if you use right tool, it's something different. So just mirror. So I leave everything as is. So I define a 1.2 millimeter nose radius, insert C type, and I will see the top side. So the top side means this. I also change this one underside, but I need to change the folder to right to left. This is another option, but I don't actually. This is my convention actually. The top side, the left. Okay, this is the tool. So in the program order view, I need to create an insert again operation based on. I select the tool, non-form method, and the geometry avoidance main. So I'm going to create the first path. The axial trim plane is in the facing. You will actually trim until this point here. This. So this says that there's -2. This is our 0. So ZM XM 0 and -2 millimeters is the part. But it can be also point. This is the point. So you can change it to either distance or point. Let's say -1.5 millimeters, and this is, as you can see, there's a 0.5 millimeter stock for the finish. You can either change the direction from towards the center or away from the center, but I'm going to start the outer, then go through the center. And also, let's check that it's finished. The cutting is a blue line. The I think it is magenta. Magenta is the retract motion. So I want to extend the retract motion uh, past the actual the center line. The cutting should be come through the center line and past the center line 2 millimeters here, so that at this position the speed will be maximum. And pass here and leave here. So I can also change the retract motion type relative to cut. For example, let's say 90 degrees, 2 millimeter extension and 2 millimeters retract moment. Yeah, this is another position. So I don't have some kind of small peak here. So I clean everything. And also I can start a curve motion, you can actually change the definition. You can just continue the straight line, 2 millimeters, let's say 2 millimeters again. Yeah, comes straight to the start the cutting the straight motions. Okay, this is the first cutting tool pad. And you can also adjust the feed rate and the speed. The speed is the surface speed. You can give, for example, different values, but the maximum RPM means that if you select the maximum RPM, it will actually retain 150 millimeters per minute cutting speed up to some certain places by increasing the rotational speed. But in some case, in at some certain points, it will start increasing exponentially because linearly, but it will go to the infinity because at the center the radius will be zero. You can remember the formula pi d n, which is cutting speed is equal to pi times the diameter of the workpiece and the rotational speed. If you try to keep the surface speed is 150 millimeters, 150 meters per minute, uh, and also if you reduce the diameter to somewhere here or here, you need to increase the rotational speed. So at some certain point, at the center line, it will go to infinity because the radius will be or diameter will be zero. So you need to actually prevent the machine to increase the speed, rotational speed to infinity. You can actually put some 100, 1500 RPM limit. It will maybe when the tool is came in this position, maybe it can be 150, 1500 RPM. And also the speed will reduce to 120 or something. Since we are doing a feed rate, we can use the millimeters per revolution. For example, this can be our cutting speed. Yeah, this is basically the toolpath. Yeah, you can maybe mount up. Yeah, there is. You can simulate here. You can simulate. Yeah, start. Yeah, this is. You can reduce the speed. This is the face turning, and we can actually add another operation. For example, we can add some rough turn operation, the same tool. So again, we need to put some axial limit because this end is the machine side, so there will be some fixture or chuck jaws to hold the part in the machine. So you need to measure how much you can actually cut from this end from 0, 0 to here. So let's say leave 50 millimeters here. So we now have, I guess, 200, 240. So let's say that minus 200. As you can see, there are some other tool paths here. Since we cut it, we need to actually prevent the radial direction. So we Can put some point here. Just cut the outer surface. So let's say constant speed 1.5. Generate. And also as level. And also leave some stock for the finishing. This time I'm going to add some rough stock to radial direction. So this is a 1.5 millimeter depth of cut. And the single pass roughing operation. So I can actually correct the non-cutting moves. Let's say it's a relative and no extension, and it can be 180. Sorry. Ah, let's create quickly again. So 200. Let's say point EF. Constants 0.5. And add some stock. Let's add 0.5 millimeters stock. And also I want to actually correct the retract position. 80. Oh, let's say 0. Let's length is 2. This is now basically okay. Let's change here as well. Engage. Again. Relative to cut 2 millimeters. Okay, this is the first basic turning operations. So you can actually try adding the same operations with the 0.5 millimeter cut to cut the finish. Okay, let's see in the next tutorials.